This is lecture number 5 in vectors. We are starting with three-dimensional coordinate system. In last lecture, we had done two-dimensional vectors in two dimension. We had done vectors in two dimension. That is vectors in a plane. Now we are going to see vectors in space. So you can also give the heading here as vector in space. For writing vector in three-dimensional coordinate system, you could have even written vectors in space. Vectors in space. So now you understand that if you have a vector in space, now in order to locate a point, in space, you should have the knowledge of three-dimensional coordinate system. Okay. So what happens in 2D system? What happens in 2D system and in 3D system? See, in 2D system, you have the y-axis and x-axis. In 2D system, you have y-axis and x-axis. Now, what happens in 2D system is everything is in a plane. So this is if this is y-axis and here you have x-axis, then everything is in a plane. Okay, you have xy plane. This is xy plane. This is xy plane. So this plane is xy plane. You have a point in a plane. You have a point in a plane. Now this point has the x coordinate and the y coordinate. So simply two numbers a and b will locate the point completely, a comma b. But what if you have a point in space? Okay, 3D system. Now for 3D system, what we have is, for 3D system, we will have the third axis, that is a z axis. Okay, so let's go for 3D system. And when we go for 3D system, there are few changes that you have to understand. See, first is in 3D system, there will be three coordinates. There will be three coordinates. There will be three coordinate axes. So I take the first one as, see, this is one coordinate axis. Here I have the second coordinate axis. And the third coordinate axis is this. You will have to wait for a while in order to have the actual vision. You will understand that how is this 3D, okay? A bit of imagination will make this clear. Remember that if it was a 2D system, you would have written this as y and this as x. But in 3D system, it is not like that. In 3D system, it's not like that. So how is it? In 3D system, you have these two axes as x and y axis. Which axis? See, this axis which is coming towards you. See, these two axes these two axes will be defining the plane of the page. Which two axes? These two axes will define the plane of the page. For making you understand that, I will have to first remove the third axis. I will remove the third axis. See this, let me remove this third axis. Now you will understand. See these two axes, the two axes which are left now, these two axes define the plane of the page. Okay, you will have to imagine a bit. Now here it doesn't look like that, but then this angle is 90 degree. Remember, this angle here is 90 degree. It's 90-degree angle. Here also it is 90-degree angle. This is 90. These two axes are perpendicular to each other. They are perpendicular to each other. Now these two define the plane of the page. What happens next is, now comes the third axis, and this axis is perpendicular to the plane of the page. It is like you keep your notebook on a table, and this axis happens to be originating from a page. It is originating from a page. So what happens is, this axis is automatically perpendicular to the plane of the page. It is perpendicular to plane of the page. You understand? It is perpendicular to plane of the page. So this axis is known as the Z axis. Okay, so it's a convention that you will call this axis as y axis. See, this is y axis. The one which is coming towards you is x axis. This is x axis, and the one which is perpendicular to xy plane is z axis. Okay, so you got these three axes. Now what we will do is, these three axes intersect each other at origin. And remember, these three axes are perpendicular to each other. They are mutually perpendicular. They are mutually perpendicular. So, see, Z axis is perpendicular to x axis and y axis. See, this is perpendicular to x axis and y axis. X and y axis are also perpendicular to each other. They are also perpendicular to each other. So you have these three axes, they are mutually perpendicular to each other. Now, when you take any two of the axes, any two of three axes, you will define a plane. So let me first tell you what is XY plane. So see, this plane is XY plane. This plane here is XY plane. I'm using yellow color. See, this plane here is XY plane. This plane. This plane here is XY plane. Okay. Now I show you to you like this. See, let me make XY plane. This plane here is XY plane, and here you have, this is ZX plane. See, I will show you now ZX plane. And here you have YZ plane. This is XY plane. Then you have, see, now you will get a clear picture. After I have drawn like this, you will understand it is XY plane. Right now you see, you see a court of a lawn tennis, or maybe a court of a badminton. See, this is XY plane. And then you have two more planes which are perpendicular to this plane. See here. Now I'm going for another plane, and see, this plane is YZ plane. It takes a bit time to draw the, see, it is not that easy drawing on a two-dimensional screen. I'm trying to show you a 3D or three-dimensional thing on a 2D. So it will definitely take slightly more effort, but I will make it clear. Don't worry. Be with me. I'll make this clear. See here. What is this? This is YZ plane. Sorry, this is XZ plane. I'm sorry. This is XZ plane. The pink one is XZ plane. This is XZ plane. It is vertical plane. XZ plane is constituted by the x-axis and z-axis. The x-axis and z-axis. And then you have YZ plane, the orange plane. See this one. Now, when you see the XY plane, okay, let me tell you that this XZ plane will intersect. It will intersect the XY plane, and it intersects XY plane along a line. I will show you that line. See, this is the line of intersection of two planes. You see this line? This is the line of intersection of which two planes? The XY plane and XZ plane. See, XY plane and XZ plane, they intersect each other along this line. And you know what will happen? This after intersection, the XZ plane will move down like this here. See here. You will also be able to see it, see here, this way. Yes, this is definitely extended, From here, you will not be able to see, but then you can see here, see this one. Check this, but it will be visible only after this. It will only be visible after this. It will go down like this. It will go down like this. This is the extension of XZ plane. Then you have the YZ plane. See, this is YZ plane, the vertical. You see this? This is YZ plane. YZ plane. YZ plane is constituted by the y-axis and z-axis. This is YZ plane. So now you can, yeah, I hope it is clear to you. You have three planes intersecting each other. You see this three plane. This is YZ plane. This is YZ plane. I am right now moving my pen in YZ plane. This is YZ plane. Okay, I'm moving my plane in XZ plane. See, this is XZ plane. I hope you can all understand. This is XZ plane. And now finally I'm moving my pen in XY plane. See, this is XY plane. So these are three planes. The XZ plane and so here you have XZ plane, XZ plane is also known as, it is also known as XOZ plane, one and the same thing. You can also include the origin in that. So XOZ, XOZ, you understand? It is also known as XOZ plane. Same way, the XY plane can be called as XOY plane and YZ plane can be called as YOZ plane. Forget about that now. See here. What I want to tell you is XZ plane and XY plane, these two planes intersect each other, intersect on a line. They intersect on a line. And what is that line? Line x-axis. they intersect along x-axis. Okay, the best would be to write they intersect along x-axis, along x-axis. See, this is the axis along which these two planes intersect. Moreover, see, in xz you have x, and in xy also you have x. So the intersection of these two planes will intersect along x-axis. Next is, see, yz plane and xy plane intersect. They intersect along, see, yz, you got y here, xy, you got y here. See, yz, which is yz plane? Yz plane is the vertical plane. You remember I showed that vertical plane here. See, this is yz plane, this is yz. Okay, yz plane. And which is xy plane? Xy plane is the horizontal sleeping plane, sleeping one. See here, this plane is xy. Now these two planes will intersect each other. It is needless to show, but still, see here. This is the point of intersection. This is the point of intersection. I'm sorry, the line of intersection. The two planes always intersect along a line. Remember, they are planes. They will not intersect they will not intersect at a point. They are not lines, they are planes. So the planes will always intersect along a line. Okay, if you have two lines, remember, when you have two lines, the lines intersect at a point. Check, the lines intersect at a point. This is the point of intersection of two lines because they are lines. But here what we have in this, we have plane. The planes intersect not at a point, they intersect along a line. So here what we will write? We will write here that YZ plane and XY plane intersect along Y axis. Okay. Now similarly, you can write the third one. And what will that be? That will be XZ plane and XZ plane and YZ plane. They will intersect. YZ plane intersect along Z axis. They intersect along Z axis. You can have here. See, which one is the XZ plane? Which one is the XZ plane? The XZ plane is this one. See, right now this is XZ plane. Check this. This is XZ plane. And what is the YZ plane here? YZ plane is this one, the vertical plane here. This is YZ plane. So where would they intersect? They would intersect always here. See, along Z axis. See, this is the point of intersection of these two. You check this, they are intersecting here. You know, this is the point of intersection. They are intersecting here. Because of unavailability of proper space, okay, the diagram I couldn't draw very clear diagram, but then I hope you all can imagine what I'm trying to show here. A bit of imagination will definitely help you out. So now let us take the discussion ahead. Here we have Z axis. This is Z axis. This one is Y axis and this one is X axis. Okay, I have a point in space. As I showed you the compartments, as I showed you the plane. Now, I showed you three planes. Now, these three planes will intersect each other. And because of their intersection, what will happen? We will have total 8 compartments. 8 octants we will have. We will have total 8 octants. We will have here total 8 octants because of this. I will show you those octants now. So you have a 3D system here, three-dimensional system, X, Y, Z, and think there is a point P in space which has X, Y, and Z coordinates. Okay, now I will show you that where is this point P. Point P has X, Y, and Z coordinates. Now, what is meaning of X coordinate of point P? X coordinate is X coordinate is X coordinate of P is displacement. It is displacement of P along x-axis. Okay, it is the displacement of point P along x-axis. So this is x-axis. So displacement of P along x-axis. Suppose I write here P as 3, 4, 5. So point P has x displacement 3 units. You can check here. See, this is x, this is 1, this is 2, this is 3. Okay, so along x-axis, the displacement is 3. Then y displacement here, the y coordinate is 4. So y coordinate, see here, 1, 2, 3, and 4. The y displacement is 4. And then z displacement here, the displacement along z axis is 5. So you have 1, 2, 3, 4, and 5. This is 5. So where is this point P? The point P, if you want to check, you will have to first go in the direction of x-axis 3 units. See, you will go in the direction of x-axis 3 units. This way you go 3 units. Then from there you will have to go in the direction of y-axis 4 units. This way you go 4 units. You check this. You move 4 units this way. See, I'm sorry. See, in the direction of y-axis, you move 4 units. And then in the direction of z-axis, you move 5 units. See, in the direction of z-axis here. So now you all can understand, this is 3. See, in the direction of x-axis, 3. In the direction of y-axis, 4. And then in the direction of z-axis, 5. So 3, 4, 5. So where is point P? Point P would be somewhere here. See, this is point P. 3, 4, 5. 3, 4, 5. And if I join this point P, if I join this point P with origin, I will get this as OP bar. See, this is vector OP bar. OP bar. You see this vector OP bar? Now I'm going to show you that how to write the position vector of this point P. What am I going to show you now? I'm going to show you how to write the position vector of point P, which is in space. It's in space. It is not in a plane, it is in space. Okay, so this is what we are going to do now. Yeah, one more thing. Suppose I have another point Q, 3, 4, -5. Then where would that point be? See, the x and y displacement are same as P, 3 and 4. Okay, so you come along x-axis 3, you come along y-axis 4 units. But when it comes to z-axis, the displacement of point Q is -5 along z-axis. So what you will do, you will first check -5. So see, this is -1, -2, -3, -4, and -5. See, along z-axis -5. So what will you do? You will have to go You will have to go 5 units down here. You check this. You have to go 5 units down, and here you will. So 3, 4 and minus 5. 3, 4 and minus 5. So where is that point Q? Point Q is here. This is point Q, which is 3 comma 4 comma minus 5. Like this, you can have location of all the points in space. You can have location of all the points in space. One more point I'll take. Suppose I have R, point R I have, and R is 4 comma minus 6 comma 2. So along x-axis it is 4. Along x-axis you have 4. So this is 4, 4. Then along y-axis it is negative 6. Along y-axis negative 6. So see, this is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. This is negative 6. And then 2. 2 is here. So see, how would I move? I'm taking another color this time. So let's do it. See. So you move 4 along x-axis. Then you go negative 6 along y-axis. So see, so from 0 to 4 you come along x-axis. There onwards, from 4 you go negative 6, and then what do? You have to go positive 2 along z-axis. From here onwards you have to go positive 2. So this is positive 2. Okay, and this one is point. This is point R. What are the coordinates? R is 4 comma minus 6 comma 2. And if you join this R, if you join this point R with the origin, okay, you get the vector OR bar. This is vector OR bar. Okay, and what is this vector? This is OP bar. We have to get the position vector of these points in space. So the next thing that I'm going to teach you is how to get the position vector of these points in space. So here we have z-axis, x-axis. I'm sorry, this is not x-axis, this is y-axis. The x-axis is the one which come towards us. Okay, and this is x dash. Okay. I have a point in space which is p x comma y comma z. Okay, so its x displacement is x units. So x could be positive or negative, but irrespective of that, we are going to take positive. Okay, so say here x units is x unit is this big. So I take x as this. This is x unit which I took. Then I have the y. I have to move y units in the direction of y-axis. So think this is y here. Okay. Then I have to go for the z displacement. So think z is this big. This is z. Okay. Think this is z. Fine. So now what I will do is, see, this is origin here. I call this point as A. I call this point as A. And this point is, okay, I will name this point as N. This is my point P. This is my point P here. Okay. Now what I will do is, this is from O to A is X units. This is X units, X displacement. I just showed it. This is X units. Okay. From O to A. Here it is X. Like you showed here. See, here it is 4. Okay. Because the X coordinate was 4. So the same way here it is X. Okay. This number is X. This number is X here. Then this number a to n, how big is OA? OA is equal to x, AN is equal to y. This is y. And what is NP? NP equals to Z units. Okay. Now what I will do is, using these three, I will complete a cuboid. Okay. So here, see this displacement here is, always remember, same as this displacement here. Okay. This is y displacement. So actually, you you have AN as y, so as OB. This point I'll call as B. Okay, OB is also y. OB is y, remember. These two are equal because they are along y-axis. See, this and this, they are equal. Okay, they are equal. Both are equal to y. Next, now I have the NP. So NP here, and NP here is NP is equal to Z. This is Z, right? And I take it here, Z. So this is Z. So OB is also equal to Y. AN is same as OB. And this is, I write this as point C. You got that? This point I write it as C here. This is point C. And how big is this? This is Z. This is Z. As PN is, then P is Z. So this is equal to OC. Now I'll complete the cuboid. See, for completing cuboid, what I will do is, let me first complete the quadrilateral, that is a parallelogram in XY plane. Can you all see that parallelogram in XY plane? See, this is OANB. This is parallelogram in XY plane. It is in XY plane. See this plane. You see this plane, XY plane, parallelogram in XY plane. What is that parallelogram? It is OANB, this parallelogram. Now, with the help of this parallelogram, I will make a cuboid. Okay, see here. Now, what I do is NP, this is NP. Okay, this is height of the cuboid. So I will take it here, and same NP, I will take it here. Okay, and at the vertex O, it is already there. Then what I will do is I will join these. See here. Simply join them. See. And now you have a cuboid ready. See, this cuboid which you have, this is in first octant. It is in the first octant. There are total 8 compartments. Try to understand. Try to understand this. When you have x-axis and y-axis, when you have x-axis and y-axis in 2D plane, then you have 4 quadrants. You have 4 quadrants: first, second, third, fourth. These are quadrants. But now quadrant, qua stands for fourth, 4. Like you say quarter, that is 1/4. Quadrant, this is 4. This prefix QUA, it stands for fourth, 4. It stands for 4. Now what you have is, you don't have quadrants because there are 3 coordinate axes. So they will, when they intersect each other, you will have 8 octants. And this cuboid is one of those octant. It has positive of x-axis. Try to understand. This is in positive of x-axis. You know, this has positive of x-axis, positive of x-axis, positive of y-axis, and positive of z-axis. Okay, I could have had, see, if I push this, if I push this cuboid that side, what will happen? It will have negative of x-axis. You check this. If I push the cuboid, if I take this particular point at the origin, what will happen? The and rest all same. It will have negative of x-axis, positive of y, and positive of z. Okay, so you have total 8 octants. There will be total 8 octants in this. Namely, see here you will have one octant, you will have positive of x, positive x, y, z. Okay, see the one octant you will have is x positive, positive, positive. Then second you will have positive, positive, negative. You see this? Then you will have x positive, negative, positive, positive, negative, negative. Then you will have x negative, negative, positive, negative, 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 positive, positive, and negative, positive, negative. See, total 8 octants you have. 8 octants. 1, 2, 3, 4, 5, 6, 7, 8. 8 octants you have. Right now we are in the first octant. See, right now we are in the first octant. Okay, where x is positive, y is positive, and z is also positive. So where is point P? Point P is here. This is point P, and the coordinates of point P are x comma y comma z. See, this is x comma y comma z. What I do next here is, see, as we all know, on x-axis we will have positive and negative numbers. So see, this much is, think this is 1, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and so on. So what is this point? What is this point? This point is x. X is nothing but a number. Like you have 1, 2, 3, 4, 5, 6. X is some number. So this is x here. So here right now, as of this example, x is in between 5 and 6. X is in between 5 and 6. So x is equal to 5 point something. Okay, 5 point something like that. Okay. So what I'm trying to show you here is that we will have one unit here on x-axis. We will have one unit here on x-axis. Similarly, we will have one unit here on y-axis. You check this, and so on. We will have one unit here on z-axis, and so on. Right? Now, check this out. I will define a vector which is a unit vector in the direction of x-axis. I will define a vector which is a unit vector in the direction of x-axis. See, this big vector in the direction of x-axis. It has magnitude equal to 1 unit. That is why when it starts from origin, it reaches 1. When it starts from 1, it reaches 2. When it starts from 2, it reaches 3, and so on. Okay. So if I want to have a vector in the direction of positive of x-axis having magnitude 3, are you getting it? So it will be 3 times of that unit vector. This unit vector, I name it as I cap. How do I name this? I name this unit vector as I cap. This is I cap. Similarly, I define a unit vector in the direction of positive of y-axis, which is j cap. It is j cap. And then I define a unit vector in the direction of positive of z-axis, which is k cap. See, this is k cap. If I want a vector which is in the positive direction of x, which is in the direction of positive of x-axis, and it has magnitude 3 units, so it will definitely be collinear with I cap. This vector here is collinear with I cap, and it has magnitude 3 units. So definitely it will become 3 I cap, a scalar multiple of I cap. You know what is a scalar multiple of I cap? Okay, a scalar multiple of I cap. If two vectors are collinear, one vector is a scalar multiple of other vector. This smaller vector is I cap, the bigger vector is 3 times of that, so it is 3 I cap. So if I have a vector which is x times of I cap, if it is x times of I cap, it will become what? X I cap. Look at this vector a n bar. Vector a n bar is x times of I cap. So it is x I cap. So here I will write a n bar. I will write here vector a n bar is equal to x I cap. Now let's go to j cap. I have here a vector j cap, and suppose if I have a vector which is in the direction of positive of y-axis, and it is 4 times of j cap, then this vector you will call it as 4 I cap. What you will call this as? You will call this as 4 I cap. This is 4 I cap. 4 I cap. Because I'm sorry, it is 4 j cap. I'm sorry. It is having magnitude equals to 4 units, and it is in the direction of j cap. So it is 4 times of j cap, and hence it is 4 j cap. It is 4 j cap. So likewise, if I have a vector which is in the which is collinear to j cap, but it is y times, see this number is y. How big is this vector? This vector has magnitude y units. See, this vector has magnitude y units. Y. So how big is this vector? This vector is yj cap. This vector from O to B, OB bar is yj cap. OB bar is equal to yj cap. And remember, if OB bar is yj cap, AN bar is also yj cap. AN bar is same as, see, AN bar is equal to OB bar, because these two vectors are parallel and they have same magnitude and they have same direction. They have equal magnitude and same direction. So OB bar is same as AN bar. AN bar is how much? Y times j cap. It is yj cap. Now come to the vector which is in the direction of positive of z-axis, that is, it is collinear to k cap, and it has magnitude z units. How big is this? Z units. So this is zk cap. It is in the direction of positive of z-axis. So it is collinear to k cap. It is in the direction of k cap, this vector. So here you have OC bar is equal to, OC bar is Z times of K cap, ZK cap. It is ZK cap. OC bar, OC bar is equal to ZK cap, which is equal to, NP bar. You know, this one is same as OC bar is same as, I'm sorry, OC bar OC bar is same as NP bar. This is ZK cap. Now let me join point O with A. And what will this give me? This will give me ON bar. This will give me ON bar. Fine. And where do we have to reach actually? What is our aim? What is our aim? Our aim is OP bar. Remember, where do we have to reach? We have to reach to OP bar. So what I did, I, in order to get the OP bar, first I go for ON bar. I go for ON bar. So see here, what do I write? I apply triangle law of vector addition in triangle OAN. Okay, so I write here, in triangle OAN by triangle law of vector addition. So here I write, in triangle OAN by triangle law of vector addition. So see what you have. You have OA bar, check this, OA bar plus, look at the direction, OA bar plus AN bar is equal to ON bar. You check this from here to here, then here to here is same as here to here. So I apply triangle law of vector addition. So I get here, ON bar is AN bar plus, I'm sorry, ON bar is OA bar plus AN bar plus AN bar. So what is ON bar equal to? OA bar, OA bar is XI cap. I had made a mistake here, students. See, this is not AN bar. I'm so sorry for this. This is not AN bar. It is OA bar. I am extremely sorry for this. This is OA bar. Okay. This is OA bar. OA bar. So OA bar is XI cap. This is XI cap plus AN bar. What is AN bar? AN bar is YJ cap. So see, we got ON bar. Vector ON bar is XI cap plus YJ cap. Next, what I will do is, I have got another triangle. You check this another triangle. The triangle is ONP. Look at the triangle ONP. I write, in triangle ONP by triangle law of vector addition. So see, in triangle ONP, what you will have? ON bar, check this, ON bar plus NP bar is equal to OP bar. Okay, so here I write, OP bar here is ON bar plus NP bar. So OP bar will be equal to ON bar. ON bar, just now you found out what it is. It is XI cap plus YJ cap. And what is NP bar? NP bar is ZK cap. See, NP bar, here we have already written. NP bar is what? NP bar is same as OC bar, which is equal to ZK cap. And this is OP bar. Students, check. You got the position vector of point P, which is in space. And what is that equal to? You got it as XI cap plus YJ cap plus ZK cap. So P bar is XI cap plus YJ cap plus ZK cap. Okay, this makes a very bold statement. What is it? That if a point, you know the coordinates of a point in 3D space, if you know the coordinates, okay, if a is x1 y1 z1, then OA bar, that is position vector of point A with respect to OA bar is equal to x1 I cap plus y1 j cap plus z1 k cap. Just now we did it. See, if m is x2 y2 z2, then OM bar, that is position vector of point M with respect to O, will be x2 I cap plus y2 j cap plus z2 k cap. You got this? If p is minus 3 comma 7 comma minus 12, then OP bar is minus 3 I cap plus 7 j cap minus 12 k cap. Okay, I hope you followed this. Now, though, so this is done. We have written the position vector of a point P. We have written the position vector of a point P with respect to O when we know the coordinates of point P. Now we are going for the magnitude. Now check this out, students. See here. Look at the triangle OAN. The triangle OAN is a right angle triangle, remember, because this angle here is right angled. This is right angle. Okay, this is a right angle. Because when you reach point A, from there you move in the direction of positive of y-axis. Now you know x and y-axis, they are perpendicular to each other. Okay, they are perpendicular. So this angle is 90° here. So in triangle, what I'm now going to do is, see, I'm working for the magnitude of vector OP bar. So in triangle OAN, I apply Pythagoras theorem. So what you will get when you apply in triangle OAN, I apply Pythagoras theorem. So I get here ON square equals to OA square plus AN square. Okay, so I got here ON square as x square plus y square. Got it? Yeah. Now next. The next is I go for triangle. ONP. Look at the triangle ONP. And remember that triangle ONP is also a right angle triangle. Why right angle triangle? It is because once you reach point C, from O, when you reach N, from point O, when you reach point N, remember you are still in XY plane. Get this out. When you reach from point O to point N, you are in XY plane. Which plane you are in? You are in XY plane. See this. This is XY plane you are in. Now, after reaching here, when you start going up, you getting it? When you start moving up, actually you are moving in the 90 angle direction. This is perpendicular. Okay, you are moving in the direction of Z axis. So you know ON, vector ON bar is perpendicular to vector NP bar. So what I will do, once again I will apply Pythagoras theorem in triangle ONP. In triangle ONP, I apply Pythagoras theorem. So here I write, see here. So when I apply, what I get OP square, because OP is the hypotenuse. Okay, so I get OP square equals to ON square plus NP square. Okay, so I have here OP square equals to, what is ON square? We have already found. This is x square plus y square. And what is NP square? NP is Z. So you have Z square. You have here Z square. So what is OP equal to? OP equal to square root of x square plus y square plus z square. See, this is another very bold statement. You have to follow here. This is very bold, another statement. What is it? See, when you have a point P in space, when you have a point P in space which has coordinates x, y, z, then the position vector of point P is xi cap plus yj cap plus zk cap. The position vector is given by xi cap plus yj cap plus zk cap. Okay, and the magnitude of that vector, see, the magnitude of the vector is given by square root of x square plus y square plus z square. The magnitude is given by square root of x square plus y square plus z square. Okay, so here, as we have written three examples, 1, 2 and 3, 1, 2 and 3. See here, what will be the magnitude of OA bar? So see here, mod of OA bar will be square root of x1 square plus y1 square plus z1 square. What will be mod of OM bar? Mod of OM bar will be square root of x2 square plus y2 square plus z2 square. And mod of OP bar will be square root of minus 3 square plus 7 square plus minus 12 square plus minus 12 square. That is equal to square root of 9 plus 49 plus 144. That is equal to square root of, this is 58 and this is 144. So 144 plus 58, 202. 202. Square root of 202 units is the magnitude here. So I explained you 3D, I explained you three-dimensional coordinate system. Then I also explained you vector in 3D. I also explained you vector in 3 dimension. Okay, so these two things we did today. So I hope you must have copied all this. If not, then you can copy it. See here, there are a few more things which I would like to show and which I would like to teach you. Let us write the coordinates of different other points here. Okay. So let us write coordinates of some more points here. Say, if I want to write coordinates of point, if I want to write the coordinates of origin, so the origin will be 0, 0, 0. The coordinates of origin will be 0, 0, 0. Okay. So origin has coordinates 0, 0, 0. Then if I want to write the coordinates of point A, look at point A. Listen to that. Point A is on x-axis. So its x displacement is x. See, from here to here, the x displacement, the displacement along x-axis you give by number x. Now, the displacement of point A along y-axis is 0. Why 0? Because point A is on x-axis. So it is neither towards the positive of y nor towards negative of y. So x coordinate will be x. X coordinate is here. The x coordinate of point A is x. The y coordinate of point A is 0 and z coordinate is also 0. Z coordinate of point A is 0. Let's come to point B. The x coordinate of point B is 0. Point B is on y axis. It is on y axis. Its x displacement is 0. If you check point B, it has neither positive x displacement nor negative x displacement. With respect to x, it is at at rest. It is stationary. It is on y axis. It has x displacement 0, y displacement is y, and z displacement is also 0. It is neither up nor down. Okay, it is on y axis. Now come to point C. The coordinates of point C will be, the coordinates of point C will be, x coordinate is 0, y coordinate is 0, and z coordinate is z. Okay, then we will move to coordinates of point N. Okay, I will have to remove this part. So what I suggest you is that if you want to copy, then you will have to pause the video at some point and copy this. I'm writing the coordinates of point N. See here. Point N, look at point N. Its x displacement is x. You can check the displacement of point N along x-axis. Displacement of point N along x-axis is x. Okay. This displacement, point N, the x displacement is this, and you know this is same as this. It is x. The x displacement of N is x. The y displacement, look at the y displacement of point N along y-axis. So see, along y-axis it is y. You check this. Along y-axis it is positive y, and along z-axis it is 0. It is 0. Why? Because this point N is in xy plane. You check this. The point N is in xy plane. Point N is in xy plane, and you know it is see, this is your xy plane. This is your xy plane. This is xy plane. It is neither up in space, it is neither up along z, neither down along z. You understand? It is in xy plane, so its z coordinate is 0. Now come to point. Let's have now point. See, I will write this point as, let me write this point as R. The x displacement of R is x. Okay, its x displacement is x. Along x-axis, it has displacement of x. Its y displacement is 0. Its y displacement is, I'm sorry, point R. Point R. Point R has x displacement 0. It has y displacement y and z displacement as z. And it has z displacement as z. Point R has x displacement 0. I hope it's clear. Because point R is in which plane? It is in YZ plane. It is in YZ plane. Point R is in YZ plane. You can check. See, this is YZ plane. It is YZ plane you have. This is YZ plane. YZ plane. The vertical plane. The vertical plane. This is YZ plane. So the point which is in YZ plane, its displacement along x-axis will be 0. Then we have point here. Let me write this point as point Q. I write this as point Q. I write it as point Q. This point Q is in XZ plane. It is in XZ plane. So if it is in XZ plane, what will happen? Its X displacement is X. You can check the displacement of point A and displacement of point Q. They are same. Displacement of point A along x-axis, displacement of point A along x-axis and displacement of point Q along x-axis would be same. These two displacements would be same. So here you have X, and the displacement along Y is 0, displacement along Z axis is Z. So we have written the coordinates of all these points, and we also understood that when a point is in xy plane, when a point is in xy plane, its z coordinate is 0. When a point is in yz plane, its x coordinate is 0. And when a point is in xz plane, its y coordinate is 0. We understood this. Okay. See here. One more thing. Point A Point A is on x-axis, so its y and z, both the coordinates are 0. Point B is on y-axis, so x and z coordinates are 0. Point C is on z-axis, so x and y coordinates are 0. I will remove this complete here so that you are left only with the diagram. So having understood how to represent, how to write the position vector of a point in space, when you know the x, y, and z coordinates of a point, the next is to find the displacement vector. So now we are going to have displacement vector. See, I have a point P, I have a point P here in space whose coordinates are x1, y1, and z1. Point P has coordinates x1, y1, z1. Another point Q has coordinates x2, y2, and z2. So if I write OP bar, these 2 points are in space. Okay, I have drawn x, y, and z axis. So OP bar, which is equal to small p bar, it is x1 I cap plus y1 j cap plus z1 k cap. And OQ bar, which is equal to small q bar, it is x2 I cap plus y2 j cap plus z2 k cap. Okay. What I am interested in is vector PQ bar. I am interested in vector PQ bar. I want PQ bar. So how will I write vector PQ bar? See, we have already done in earlier lectures the position vector of a displacement vector. See, PQ bar will be given by Q bar minus P bar. PQ bar will be given by Q bar minus P bar. Okay, so Q bar is x2 I cap plus y2 j cap plus z2 k cap. So x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap plus y1 j cap plus z1 k cap. Okay. So when you open this bracket, you will get x2 minus x1 I cap You will get, see, x2 I cap minus x1 I cap. So I cap will be common. You will get x2 minus x1 I cap plus you will get y2 minus y1 j cap plus z2 minus z1 k cap. You will get this as pq bar. And the magnitude of pq bar, that is mod pq bar, you will write as square root of what you will write, square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay, just commit this to your memory. ये सिर्फ you will have to remember this. So x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square plus z2 minus z1 square. This much you will have to remember. You can also copy this